So this is part two, a continuation of our first video. So I want to go back again to just make sure that all of this is making sense. Quick reminder. We're looking at these systematic reviews and these meta-analysis, and I'll go more into meta-analysis because they can provide convincing and reliable evidence that is relevant to what we're looking at, right? Their value, or one of the main reasons why we utilize these, is because when the results of the study show clinically important effects or similar magnitude, sometimes the conclusions are less clear when the included studies have different results. And that's where you may often see variability, right? In an attempt to establish whether studies are consistent, we utilize meta-analysis to present a statistical test of heterogeneity. So the meta-analysis within systematic reviews are used to present a statistical overview and test to determine, is there variability, where and why? Okay? So we do that to determine whether there are genuine differences underlying the results of the studies, or whether the variations in findings is compatible with the chance that it just might be that they're really all the same. Which in that case, if everything is pretty much the same, not a lot of variability, that would again mean there's homogeneity. Okay? When we look at these systematic reviews and the meta-analysis, we start out with, again, the idea that the null hypothesis, or we're testing heterogeneity to confirm the null hypothesis, for the null hypothesis that all studies are evaluating the same effect. That's our first thought. Then we go into doing the statistical test to determine if that's actually true. Okay, now let's go back and take a look at what this study is talking about from, let's start from page you know what, let's just start from the results section. That's a good place to start. So if we start at the results section, let's take a quick look. They did a literature search. They came up with 214 references that they identified. Independent scrutiny of those titles and abstracts identified 26 potentially relevant articles. So they had devised a question. They found 214 articles that could be related to the question they were asking, and after going through their elimination process, they found 26 articles that focused on what they were actually questioning. And of those 26, 23 were excluded because they were abstracts, case forms, case series, narrative reviews, basically things that they weren't, or types of articles that they weren't looking for, right? So they abstracts because, of course, that's not enough. Case reports, case series, narrative reviews, or included children with diagnosis other than cerebral palsy. So these are all the things that they're excluding. So just like your previous studies that you looked at, you have your inclusion and exclusion. So they're excluding anything that isn't related to what they're trying to find out. Okay? Now, the studies that they did utilize, they're going to talk about those and study characteristics. So I'm not going to read that part because I think that's pretty self-explanatory. So let's go down to page 680 and let's look at the methodology quality. Comparative data on design characteristics impacting of the methodology quality of each study is provided in table 3, so they're telling us where to find that information in a graph form. Of note was the lack of evidence related to psychometric properties for a number of outcomes. Now remember, outcomes are how you testing. With the DeLuca trial, which was one of the studies, including the pediatric motor activity log, also the emerging behavior scale, and the toddler arm use test. Each of these tools were developed specifically for this trial, and the psychometric properties have not been reported. So basically, the outcome measures that they, or the outcome measures that they used, we've previously talked about validity and reliability and gold standards of those, and we're going to talk about it further later on. But because those were designed just for that study, there wasn't enough evidence to utilize those for this systematic review. Remember, they're looking for valid and reliable data. So each of these tools were developed, again, specifically for that trial, and their properties have not been reported, so they won't use it. The Sung et al. Did not report on randomization or allocation, so didn't confirm if there was randomization or allocation, concealment processes, or on the level of masking, suggesting poor methodology quality. All these things they found were not valid. I shouldn't say valid, but of poor quality, essentially, just like they said. These are all things we would look for within the study. So they're pointing out that it didn't have good methodology quality. Now, finding from the review analysis of DeLuca changes scores, from DeLuca's change scores from baseline level performance to immediately post-treatment at 3 weeks did not demonstrate a significant treatment effect on the Quest Dissociated Movement subscale. Okay, and it's going to go on to talk about what they found out from the studies that they looked at. But what I want to point out here is the type of stats that they're using and what you're seeing. So here, this SMD 0.91 is what we call standard mean deviation. And essentially, the standard mean deviation is a summary statistic that we utilize in meta-analysis when the studies all assess the same outcome, but they measure in a variety of ways. So example for this study is that they're all looking for the outcome for constraint-induced therapy, right, for children with cerebral palsy. But each of the studies that they actually included in the systematic review measured it in different ways. So it wasn't all the same. So they're showing you that they measured what that standard mean deviation is. And the point of having a standard mean deviation is because we have to standardize the results to a uniform scale if all of the articles we're using measure differently before we start combining them, so that we have one standard scale we can compare them all to. And that size of intervention effect in each study is relative to the variability observed within the study. So we report it as a standard mean deviation. And they're telling you what that is. Now, you're used to seeing this 95% because that's the confidence interval that they're basing it out of. What's the range of where this data fits? This 0.91 fits somewhere in this, within this, or the real number, will fit within this confidence interval range. Okay, so that's what they're reporting for each of the comparisons that they're using within their analysis. Standard mean deviation, and then a confidence interval. Now let's go up and let's talk about some other things that they're looking at. So as we keep going on, you see more standard mean deviations and then confidence intervals. They're giving you those for the analysis for the compared groups or treatments or outcomes that they're looking at. Now here's something we've talked about, but you're probably not as familiar with. So the blindly rated measure, the toddler arm use test, did not show significant differences between groups as demonstrated in the ANCOVA analysis using the F statistic 1.42 and this the p-value. So ANCOVA, as you know, is one of those lovely statistical tests that we use to compare multiple groups, 2 or more, okay? And the F statistic is what is measured for the ANCOVA, and this p-value, this p you're familiar with, the p-value. And when you remember, when you see an exact number like that, that's the exact p-value versus seeing p is less than 0.05, meaning that the p-value is less than 0.05. In this case, they're telling you exactly what that p-value is, okay? Now let's keep going down. Still, they're telling you, still comparing the studies, what's going on. I'm not going to go into detail about that. I just want to point out that they're still utilizing the standard mean deviation and confidence intervals to compare those as well. So these are the basic statistics that you're seeing within this study. They're utilizing standard mean deviations, which if you want to know what the calculation is, or the calculation, it's pretty much the difference in mean outcome between groups divided by the standard deviation of outcome among participants. So I'm just going to give you that information in case you wanted to know what it was. And then they're giving you the confidence interval of where that value lies. And in cases where there was 2 or more groups, they had to utilize the ANCOVA, which uses an F statistic, and then it gave you a p-value. Now, from here, let's take a look at these lovely graphs that you've been seeing, and let's talk a bit more about what those graphs are. Okay, let's start here on page 682. We call these force plots. Let's do a quick review of what that includes. So this force plot, oh my gosh, I'm sorry, I just realized, okay, so let me go back really quickly. This SMD, I apologize, I kept saying standard mean deviation. I meant to say standard mean difference. Okay, so let me retract that comment or that statement that I kept saying over and over. It is not the standard mean deviation, that's different. It's the standard mean difference, okay? Great, now that we got that out of the way, I'm going to take the next video to go into further detail about this force plot because I need a little more time and I'm doing this in 15-minute increments.